I extend a warm welcome to you for the first program of Fundamental of Chemistry, CHEM-3505, which will focus on the periodic table. So before we start, it is very important to highlight the profound importance of the periodic table. Henry Moseley gave his periodic law in 1887 to 1915. Moseley periodic law was based on the concept of atomic number instead of atomic weights. So after a long period of time, the concept behind the organization of periodic table was changed altogether. So instead of taking atomic weight as a principle, atomic number was considered as a base of organization of the elements in periodic table. So in early 20th century, Henry Moseley, an English physicist, conducted X-ray spectroscopy experiment on various elements, and his work revealed that the number of protons in atom's nucleus, which is known as atomic number, was a fundamental property that determined the element's position in the periodic table. Moseley realized that organizing elements by increasing atomic number rather than atomic mass led to the more accurate and systematic arrangement. So the resulting periodic law states that the physical and chemical properties of elements are periodic function of their atomic numbers. This insight provided a solid foundation for the modern periodic table, emphasizing the significance of the atomic number as a key organizing principle of the elements. Meanwhile, when the periodic table was being developed, the structure of atom was also being investigated, which also helped in revealing the true picture of the periodic table. In this connection, Dalton was of the view that matter consists of indivisible particles called atoms, and atoms of the same element are identical in mass and properties. And all compounds are formed by the combination of atoms in simple whole number ratios. J.J. Thomson discovered electron, and he proposed the plum pudding or resin bun model. He considered atom as a positively charged pudding with negatively charged electrons embedded in it like resin. In 1911, Rutherford put forward his atomic model and proposed that atom has the small, dense positively charged nucleus in their center, and the electrons orbit the nucleus at a distance. In 1913, Niels Bohr expanded upon the Rutherford model and proposed that electrons orbit the nucleus in a specific energy level and shell. Bohr was of the view that electrons travel in separate orbits around the nucleus, and the number of electrons in the outermost shell actually determine the properties of an element. So, in regard of his services, the chemical element borium of atomic number 107 in the periodic table of elements is named for him. The modern periodic table was in fact prepared by Niels Bohr, and it is also known as long form of periodic table. And it is designed on the basis of the modern periodic law, which was proposed by Henry Moseley. This is the today's periodic table of elements, which is arranged in the order of increasing atomic number, and the elements are arranged in such a way that elements with the same physical and chemical properties, which are periodically and gradually transforming, they are placed in the similar groups. So the periodic table contains 7 periods and 18 groups. Further, periodic table can be classified into 4 blocks based on the electronic configuration. For example, group 1 and 2 elements are called the s block elements because s orbitals are in the process of filling. Similarly, 13 to 18 group They are called the p block elements because the p orbital is in the process of filling. Group 3 to 12 are called outer transition elements or d block elements because their d orbitals are in the process of filling and their properties are between the main group elements, between s and p block elements. Two rows placed at the bottom of the periodic table are called lanthanide and actinide series, and they are called inner transition elements again because their properties are intermediate between s and p block elements, and also called f block elements because f orbitals are in the process of filling. Most of these elements which are appearing at the bottom of the periodic table in actinoid series, these are very recently discovered by the group of Seaborg. So Galen Seaborg actually, after co-discovering 10 new elements in 1944, moved 14 elements out of the main body of the periodic table to their current location below the lanthanide series, and now these became known as the actinide series. So he is the first person to have an element named after him while he was still alive. So he said that this is a great honor ever bestowed upon me, even better, I think, than winning the Nobel Prize. This is the list of some of the elements which were discovered by Seaborg, and the elements include plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelium, molybdenum, and seaborgium. So, after the development of Mendeleev's periodic table, there have been significant changes. For example, noble gases were discovered later of the development of Mendeleev's periodic table, and in the modern periodic table, they make up group 18 and include helium, neon, argon, krypton, xenon, and radon. These are extremely unreactive gases and very stable elements that do not combine with other atoms in nature. Similarly, lanthanide and actinide series were later discovered. Lanthanide series include the elements from atomic number 58 to 71. These are also called rare earth elements because they are hard to identify and separate, and these elements are part of period 6. Actinide series include the elements in which most are synthetic and all are radioactive, and these elements are part of period 7.